Hey everyone, welcome. I'm glad you're here. My name is Adam Granicz, and today I would like to talk to you about full stack F# web applications. Um, we're going to be looking at how you can get started with WebSharper, which is the tool set that we're going to be using, and a couple of the fundamentals we're going to touch upon Sitelets and WebSharper UI for the server side and the client side, respectively. And then I would like to talk to you about or describe briefly WebShopper forms, which allow us to collect input from the user. And then, just as a miscellaneous thing, we're going to do some charting to sort of wrap things up. So you get WebSharper shipped as project templates that you can install. So if you have the .NET CLI, you can just basically install WebSharper templates, and at that point you can create a number of projects available in that package. WebSharper Web would be, for example, a client-server application. You have WebSharper SPA for SPAs, and then HTML applications, microservices, etc. These templates typically come either in C# or F# or most likely both. Some project types are specific to F#, but most of the other application project types actually are both for C# and F#. And then once you created a project like this, you can see the Intuit and you can do .NET Run to run them. So that's, I think, pretty easy, very friendly to get started using or thanks to the .NET CLI. A few things, a couple URLs you can look at, the WebShopper website, the Try WebShopper site, I'm going to show you in a minute. And then basically, if you are a samples person, you can go into the WebShopper samples organization on GitHub and find dozens and dozens of different samples of varying complexity. And WebShopper itself is a fully open source ecosystem, is under the .NET WebShopper organization. There's core for the core repo is for the main compilers and tools. UI repo is for the reactive framework for WebSharper. Charting and forms are the two other repos that I'm going to be talking about today. All right, before I get in here, I want to show you the WebShopper website. So here you can, here's a little video that shows you how you can get started, some examples, some features. And the most interesting thing, I think, is the Try WebShopper website. So here you can find hundreds of snippets. You can filter them by the different JavaScript technology that they use. You can filter them by language. You can filter them by name. Um, for example, here's a like a to-do application. It's what 50 lines in C#. You can make changes. So the left-hand side is a live editor, so it will get you the support. I guess it works only in F#. So let's just look at the F# example for the same. So here you get the hover comments, you get code completion, red squigglies, and then the full enchilada basically. And if you're ready to compile the code, then you hit run, and it takes a couple, maybe half a second or so, and it will compile it for you, and then you can run it. All right. So basically, there are some extremely interesting snippets here I would love to show you, but perhaps the most impressive one would be this pool game. It's actually one of the featured snippets. It's about a good almost 1400 lines. It uses an older Google library called O3D for the game engine to implement this pool game. Basically, it's a 3D game, as you can tell, and if you hit the space bar or keep it pressed down, then you get a bit of a force, and then you basically can operate the ball like that. There are different options, different rendering. I'm using the mouse to sort of change the viewpoint. So it's a pretty impressive sample, I think. And just like before, you get full code completion in the Try WebSharper site for this as well. You can take the result, you can have a direct link that you can link into your blog. You can embed, or the direct link would be able to just, like have this page as a standalone page. So it's pretty nice. We actually use it in some of our blogs to actually have a live snippet that you can try that goes along with your content. All right, so let me see what else we have. So the first topic, I guess, would be sitelets, just real fast. Um, and Here what I see is that we have an endpoint type. This describes the different entry points to our web application. You can get pretty creative. So the endpoint type is typically a discriminated union. So a type that has multiple different shapes, and each shape could carry different values. For example, here the home is a shape that doesn't carry any value, but the weather is a shape that carries a string value that we call city. And then I can give in this attribute notation. This is an F-sharp attribute. In C-sharp, it would be without the angular bracket, only the bracket. In F-sharp, it's this sequence. So here I'm showing only the endpoint attribute, which allows me to, first of all, pick the HTTP verb that I want to use, and then also the path that I want this particular shape or endpoint to be accessible at. But like this arrow below says, I can actually also use other attributes to specify that I would like to receive query parameters, or I would like to receive form data for these entry points, or maybe I want to get on a post some data posted to me using JSON. All of that can be encoded into attributes annotated on the type, the endpoint type itself. So that's one half of the story. The other half is, how do you get from an endpoint value to an actual content? And that's the router part. So basically, the incoming request is parsed, and then on success converted to an endpoint value, and then the controller takes the endpoint value and then just basically returns some content. So here I'm showing different shapes. Content.page is an HTML response. Here it uses the inner homepage function, which is defined up here. Obviously, I didn't break it out, but it's a function that is supposed to compute some HTML. And then we stick that into the content.page helper. And that helper actually performs quite a lot of things. Among others, it actually tracks what kind of resource dependencies you have inside, and then makes sure that all of those resource dependencies are included in the page automatically. So you never have to include anything by hand, manually. Okay, so another typical content shape, most likely in microservices or service endpoints, would be JSON. You can take any value in F-sharp and just call it with the content.json helper. And it converts it to JSON and passes it back using the sitelet. Okay, so this is the general structure of a sitelet. As you can see, it basically allows you to sort of, in the type system, encode what kind of entry points you have and how they are accessible, and then how you and what kind of content you serve for each of those entry points. So that's a sitelet. Now, obviously, you can have a sitelet which, for some of the pages, contains static HTML and sometimes even dynamic HTML. So here, if you have a client module attributed to be JavaScript module, so basically client-side content, and if you have a function in it called main, which computes something like dynamic HTML or some other functionality in JavaScript, you can use the client or the hydrate helper to include it into your server computed HTML. And that basically is the way that you can mix client-side content into server-side markup. Sorry. So basically, doing full stack applications is as easy as that. Now, obviously, there are other um, facets here that we should explore, but maybe we'll keep that for a different talk, including things like how do you bind event handlers and things like that. We will actually see a couple of those now, but not in the context of what do you do on the server to serve something that comes with an event handler already. But I guess you can imagine that it's not that difficult at all. So how do you do, for example, HTML? How do you construct HTML? So one way would be to use HTML combinators. So a combinator just basically has, so in this case, combinators come from the WebSharper.ui package, and then from there you need the HTML module. And then once you are in the HTML module and you opened it, you have all of these combinators available to you. And then they each take two arguments. Both of them are lists. In F Sharp, the bracket notation is a list. And the first list is a list of attributes. The second list would be the list of the inner nodes contained in the node that you're defining. So as you can see here, we have a div, a p, and a br tag. And here's a slightly larger snippet. I guess we could look at it. So there's a div. Inside the div, there's an input box, which is basically an input element. And then there's a button that if you click, so note that I'm in the first list of the arguments given to the button function. So these would be attributes. So on dot click it defines a click event handler. In this case, when the button is clicked, we asynchronously call the server. So actually a function called do something, and then we give the value of what's in the input HTML DOM node. And then when the server returns, we take that data and we set the output, which is defined up here to be an H1 element. We set its text to be the data that we fetched from the server. And then we asynchronously start this. Or not asynchronously, but we start this async process, basically executing it immediately. So when we click the button, this exchange takes place between the client and the server, and the response is actually recorded on the screen because we have mutated the value of this output element, which is an H1 tag, so basically the content of the H1 tag. But that output is also included in this markup here at the final div, which basically in a jumbotron, so I guess this would be some kind of a bootstrap. So some markup that uses bootstrap CSS, because jumbotron is a typical bootstrap CSS class. Then we put inside that div the output node. All right, so let's talk about reactive variables and what they are used for. So a reactive variable is basically a piece of client-side state that is potentially connected to some element on the UI. It doesn't have to be connected to the UI. If it is connected, we call that two-way binding, because you have a piece of the model that can be asked and set and retrieved programmatically, but we can also set it using an input control that it's bound to. So here's an example of that. We create a reactive variable called var. We make an input control, which the doc module has some helpers. So doc.input actually constructs an HTML input box. No attributes, but bound to the variable that we constructed above. And then we take the view of that var, and then we map it using this function. So we take the value, the current value, and then we uppercase it. So basically, this capitalized will always contain whatever is typed in this input box, but capitalized. And then we construct a div, and we put the input box, and then we put a text view underneath, which will contain that version, the capitalized string of the contents of the text box. So here's a schematic model. Here's an input control. Here's some state in my program, which is basically the model object. And you can use programmatically, you can set and retrieve the value of this text box through this two-way binding that exists. And every time the model, the piece of the model object gets a new value, then you have a distinct value and basically you have this stream of values that happened throughout the history of that object. And you can always ask, what is your current value? And that's called the view. So we have reactive variables and then their views. Now, obviously, the fun gets, or the things get more interesting when you have some of these views reflected in the HTML that you serve back, like how we have seen here. So here we take a view and we plug its whatever current value in as a text. So that means if this view changes for whatever reason, this div will update underneath the input text box the string that it corresponds to. So this would be reactive programming without any hassle. All right. So we don't just typically use HTML combinators. In fact, my idea would be to actually almost never use HTML combinators, but instead use templates. And for helping with the templating, there's a type provider coming from UI.templating, and here's a type provider invocation. So it looks like a function, but instead of parentheses, it's actually the arguments are surrounded using angular brackets. And so here, webshop.html is a string argument to the templating type provider. And what the type provider performs is that it parses this HTML. It looks for all kinds of placeholders for attribute positions, content positions, event bindings, events that can be bound, inner templates, variables that bind or are bound to input controls, DOM references, anchors, and things like that. So these are all special attributes annotated in the HTML file. And if you run the HTML templating type provider on that file, it will dynamically at compile time generate a type space with all the artifacts that were parsed out. So in this case, if we have my template, and if it happens to have a main template in it, which obviously we coded, so basically imagine webshop.html to contain a main template with all these placeholders. So there should be a title, a string title placeholder, a DOM node, like a content placeholder for the shopping cart. That's where the shopping cart would be rendered. Another content placeholder for the items that we want to buy. So these are the selection that you can choose from the store. And then maybe there's a facility, a button at the bottom that says, okay, I'm done. And whatever's in my shopping cart, I want to send it as an order. So that would be something that you click on, and then this would be an event handler that you bind to it. And then the .doc basically seals all these instantiations and just basically makes a doc value, which is basically WebShop UI's representation of an HTML content. So here's a slightly more, so the example that we saw here earlier with HTML combinators, this is rephrased using templates. So imagine that there's a file called main.html, which has main form as a template. It has the same structure as we have seen here. So this input button, HR, H4 div, etc. And then some of the placeholders inside are marked. So for example, the button that we click on has an onClick event and it's called onSend. And then here's how I instantiate that event handler for the click event. So what happens? Exactly the same thing happened. So we call the server with whatever is written into the text box, but the text box will have a two-way binding with a name text to reverse. And remember, this is going into the main.html file. And if that's in there, then I will have access to that model using e.vars. It really should be called model. And then text to reverse is basically just a reactive variable that you can fetch the value of. And in this case, it's bound to the input control. We simply read its value, we pass it to the server, and then when it returns, we set this RV reverse, which is a local reactive variable, to that value. And that same local reactive variable is bound to the reversed field, which is a content placeholder uh, corresponding to exactly this diff here and the output of that the inner side of the diff. So this would be the HTML templating version. So no presentation layer artifacts. And I actually would prefer this kind of application structure just to avoid having to recompile your program every time you make changes to your presentation layer. So I guess we could take a look at a small example. There's a try WebSharper snippet. You can type some string here, and then we compute different views, like the original view, the capitalized view, the reversed view. We count the number of words. Is it odd or even? And then the mouse coordinates would be just a completely disjoint thing here, not related to the view of this text field, basically giving us the mouse coordinates. And then here's the whole code, assembling everything into a nice table, etc., etc. So it's about what 80 lines, 90 lines. But this is the gist, the main part. All right. Now let's talk about WebShopper forms. This is a fundamentally very powerful idea, and it allows us to declaratively define forms that become F-sharp values, so they can be passed around. So in this case, for example, if you look at this definition, if you have basically this is the composition operator. So we have different inner parts of our form. We don't know anything about how the form looks like. That's the point here. We abstractly combine like abstract parts. Like here, something will yield a user, a value for the username, and something here will yield a password. And we even put a validation on these things. We say that whatever yields the user, well, whatever that user is yielded, it cannot be empty. And if it is empty, we propagate back an error message. So here the forward pipe basically is an F-sharp idiom. It flips the order of the argument and the function being called. So imagine this as validation is not empty, and then function first argument must enter a username. Second argument, this the thing that this yield var returns. So we compose these two inner forms, the user and the password, and then we basically there's nothing else we compose, and then we compose those two with the return, which now at that point will receive a function that has n number of arguments, where n is the number of things that you have composed. So in this case it will be 2. So here is where we receive the user and the password, and then we basically just make a tuple out of it. So basically we comma them together to make a single value and pass the user and the username and the password as a single tuple. And then we enhance this whole thing with a submit button. And then we even give a run function that says, okay, when we get the user and the password, we basically zero out the reactive variables that are bound here locally to these facilities that yield the username and the password. And then we just alert, hey, welcome user, exclamation point. So this has nothing about the presentation, like how this form would be rendered. That is coming with the render function. So basically a WebShopper form is a reactive form with a custom render function that is decoupled from the form itself. So you can take the form definition and you can give different renderings. For example, if you have a web application or a mobile application, if you can detect where you're running, you can instantiate a different renderer for the same form. So in this case, the render function will mutate. So if you compose more and more things, you will need the render function to take all of those things as arguments. So for the example where we have the username and the password, we also have the submit button because we annotated with submit. In this case, if you look at the type signature, this would be a var of string, this is a var of string, and this is some kind of a submitter. And then here we actually give the HTML representation. Now, normally you should probably use a template here. Here I use HTML combinators. So here I'm saying here's a div, and then here's a username, and then next to it there's an input box with the user bound to it. So this is where we make the two-way binding. So now this user or this input control will act as the source for the reactive variable that is represented by user. And then same thing here with the password box for the password. And then we put a login button, which then basically triggers the submit facility. Now, the submitter actually is a very interesting object. What it can do is, first of all, you can ask its view, hey, by the way, what's your state? And then there's this show errors, which is a helper function that asks the view and tries to fetch all the errors from it in case there are validation errors. So it's a helper, it's a convenience. You could do this without the .show errors, just by going through the submits view and then doing some other magic. But here we receive the error messages as just a string list. We map through them. We make each message into a paragraph, and we concatenate them, and then we show them in a div. So in case there are validation errors, they would be shown underneath the whole login panel. So all of that logic, all of that presentation layer is encoded in the render function. And remember, these should be or could be template driven. Okay, so much for WebSharper forms. Now let's look at WebSharper charting just very briefly. So WebSharper charting basically has some kind of a definition which gives the source of like a data source, something that we want to chart. You can pipe it into a number of available chart types like line, bar, donut, pie chart, polar area, radar. I think these are the current limited set that we have available. Remember, WebSharper charting is an abstract library. It doesn't know anything about like different presentation layer libraries. It basically just gives you the fundamentals to represent charts of different types. And then you can have the renderers module actually contains, depending on what kind of additional NuGet packages you attach to your project. Currently, we only have two. So we have a renderer for charjets and a renderer for plotly, which can take these charts that you assemble, these abstract charts, and then render them with some potential optional arguments like size and other info. So that's WebSharper charting. It actually mirrors or tries to mirror the same API that F-sharp charting has. If you haven't heard about it, go and Google it. It's basically is an important library for the F-sharp ecosystem. So that basically WebSharper charting gives a web representation over that. So you can almost use F-sharp charting, in some cases more, some cases less with WebSharper charting, and then you get a web based charting facility. Okay, so now we talked about Sitelets, WebSharper UI, reactive templating, HTML combinators. I haven't mentioned, but WebSharper UI doesn't use DOM diffing, but it uses dynamic data flow. So it's very efficient. And we talked very briefly about WebSharper forms and WebSharper charting. Now let's look at an actual example. So we walked through a project that I prepared for this talk. Here's the URL. You can go to my GitHub and then you can go /fullstack_SPA. And then this is the application that it looks like. So I'm going to switch to Visual Studio. I have it loaded. There's a client, a server, and a shared project. The shared project has some fundamental types for encoding a transaction, and then it has an RPC interface with the get all transactions as a member on it, which takes nothing and then asynchronously returns us a number of these transaction DTOs. Now, the actual implementation is not here. This is only the interface. The implementation obviously is in the server project. So if you open the service, here we instantiate that shared API, and then we give an instantiation or implementation for the RPCs. So in this case, get all transactions. We use some random number generation and then generate random first, last name, positions, and avatars for users. And for status, we also randomly generate. And then we generate a random transaction using those. And then we basically asynchronously return 1 through 9, so I guess 9 different random transactions. If you increase this number, then you can return more. And that's pretty much it. So now let's look at the UI, so the client module. So the client has, as we have seen, actually have it running. So if you can find it, this will be it. Yep. So ignore this. I should just remove that from the template. But anyhow, so here's the dashboard, which has the table, and then it basically contains this grid that shows or displays the data that we just assembled, and you saw how we assembled that on the server side. The charting will have these 2 charts we're going to look at, and then the forms page will have 2 forms that we, if we have the time, we can look at. So, okay, let's start with the grid. So the grid. So first of all, remember everything is about templating. So when I have my index.html, I have used there was this windmill dashboard HTML project. It's an MIT licensed open source repo. I cloned it. I made a distribution out of it, and I guess what I got is this here in the public. So basically, if I open, for example, buttons, I get this nice page with all of its CSS and everything. If I open tables, I get this. So what I have done is I have copy pasted this page and I inserted into my index.html template, which I guess we can open here. So this will be in the client project. So that this index.html has copy pasted the template from those static hard-coded pages, and then I started marking them. So for example, in the menu, I marked, hey, here's an item, and it has a target UI or a target URL. The application has an application title. So this target URL, of course, is a menu item, which is a new template. So you start to see these ws-something something attributes scattered around in the template in the index.html file to define inner templates, and then inside those inner templates, for example, here's a dashboard icon template. Inside, you have potential placeholders. Sometimes string placeholders, sometimes content placeholders. Here's another template. So once I have done those markings, which should take no more than a few minutes, you can actually start writing the application logic. So let's look at the grid. So the grid is very simple. So here we have the templating type provider on index.html. So we can basically use all of the templates that are coming from it. And I am not showing you here, but there is a inner template called client transaction table with actions, which has a title and it has a number of rows. And then .doc just seals these instantiations and makes an HTML value out of it. So what do we plug into rows? And this is the interesting part. Well, it's going to be an asynchronous process. And first of all, note that this function here receives the server using this shared API value. So then what it does, it asynchronously reaches out to the server, calls this get all transactions function on it, which is an RPC served by the server. And when that returns, we get the transactions, and then we map through each of them And from each transaction, we make a client transaction row, which is a template in my index.html, which has an avatar, it has a name, position for the user, an amount that is being processed to him or her, the status, and here, look at the status. If the status that we received on the transaction is approved, then we use yet another inner template for the approved status, so that in the grid, when we show, let me find where we actually are. Okay, so this is not running anymore. We should fix that. Sorry, because I didn't start it. So you, by the way, can start. So after you checked and cloned that repo, then you do .NET run. It takes a few seconds to do its job. It basically compiles the shared project, the client project, the server project, and it starts Vita, which is a JavaScript developer server, and basically reshuffles, and it starts the backend server as well. It takes a little while. There it is. It just started. So now it gave us this page. I guess we hit Control Shift R to refresh. It's being served on HTTPS, and I don't have my SSL certificate installed, so I always have to go to this page to accept the consequences. And here's my grid populated from the server, and here are the different things that I wanted to show. So these approved status inner templates would be, for example, this guy here. So I don't want to be concerned about what classes to use on the div, etc. I just templated each of these labels, and I use them based on the status value like this. And then the date I receive as a date time. So note that date time is typically a server value that doesn't really have a representation or the same representation in JavaScript. But WebSharper basically resolves that for us. So it makes it seamless that we can pretend that it exists as a JavaScript value as well. And we just call toShort string on it to get the date, and then we get this guy here. So we get this nice little label. And then we just seal the instantiation. So these buttons don't do anything. We could have added an event handler in the template, and then once you click it, then we can do a pop-up or a delete pop-up or something like that. So anyhow, as you can see, in 20 lines, what we're doing is we are instantiating templates, and in those templates, there are placeholders that want the data to be populated. So we grab that data from the server, we wrap everything, each value, into another inner template, and we basically concatenate all the results. And then we just send those back asynchronously, and then wrap the whole thing as a doc. So this function, remember, is client transaction grid. So if you look at the main application, we jump to the bottom. So this is 120 lines. We see the main function here is our SPA entry point. So this is the whole page that we see. And that is a master template. That's main template itself. That has a few placeholders like the title, which, as you can see here, I'm going to remove this 2. And that 2 now should disappear, hopefully. Yeah, now it's only the 3 next to it. And that we can get rid of. I think it was app title. Yeah, so I added this just to show you that if I remove this from the template and switch over to the application, I see it almost instantly disappearing. So I don't have to spend time with compilation and other things. I can just change my index.html file. I can just change any of the source files, and things in the background recompile everything. And then the page, using Vita, of course, as a development server, will refresh automatically, which makes the developer workflow extremely nice. Okay, so this was the grid. Let's look at the form. The form is equally, so actually we have 2 forms. So let's see. Okay, so these are the 2 forms. So this is form number 1. This is actually just copied almost verbatim. So what I did is I copied, so here's the credits request. I copied that from the template, and I have annotated certain parts of this copied template. That, for example, this input control will have a reactive variable called name. This will have a reactive variable called requested limit, etc., etc. So now what I can use is I can abstractly compile up my or compose my form, and then I can compose the values I receive from these abstract entities as a tuple. And then I even provide the submit thing, and I even provide the run, what to do with this. And then I go and now I do the render. But instead of HTML combinators, I'm just actually going to use the actual template that I copy pasted into my master document. I just blatantly called it form 1, and it has a few placeholders. So title is the title of the whole thing. So this guy, name is the thing that we receive from the name facility. So that's going to be bound to this input control. Requested limit is going to be bound to this input control through the binding. So here, this is a placeholder that if you see the signature, it actually expects a var of string, which is exactly what requested limit is. So this requested limit is coming from the composition. So this yield is yielding the second var of string that will be mapped as requested limit, returned as the second element of the tuple, and then here we match that as a second argument on the function given to the render function. So now this has to be somehow magically transferred into an actual concrete UI, and that UI is given by the template and the requested limit control of the template. And then here we establish the two-way binding. Okay, and then of course, obviously, at the end of the form, there's a submit button, which has an unsubmit click event. And what it does, it basically calls the submitter, which is the last argument on the render function, the function that the render function receives, and we call trigger on it. So this is a credit request. So remember, we took the whole HTML verbatim from the static page. We annotated 5 places in it and marked each of the input controls. So this input control returns a boolean. This input control returns a string. This input control returns a string list. This input control is a string, and this is also a string. So these are all different shapes and different types, and they're all represented here. For example, the privacy policy is a boolean, and I don't have to do anything. All I have to do is abstractly return a boolean, and then when I handle the PP, I need to bind it to something that actually is a boolean var. So privacy policy is a var of bool, as you can see, because in the template, and I'm going to just find this, privacy policy is bound to an input control with type checkbox. And type checkbox is this guy here. And that can only be true or false. Therefore, in the type system, it's actually represented as a bool. All right, so with this, I actually took a whole block of HTML, I marked a few places, and I'm using it as a live form in my application. So this is form number 1. Form number 2 is slightly different. So form number 2 is this guy. It's validated form. Instead of the render function using one template, it actually uses multiple smaller templates, which we actually assembled. So validated text box is a function that we used here and defined here in the widgets module. It basically gives us, based on a template, obviously, it gives us something that can actually respond to an error by putting a red message underneath the failing line. So this now is fulfilled because it can be empty, but this is empty. So if I click submit, this is in a failing state and it has an error message coming from the validator. So that message is displayed in red using this validated text box control. And you can see the logic here, how the error message placeholder is placed. When there is no error message, then it's accepting state. Otherwise, we just use a template for the message itself to display this line here. And then this validated text box control is used in the rendering of this small form. So basically, we have 2 validated text boxes and a submit button, which triggers the submitter. So this is manually assembled but templated sort of widget or control based form. And the first one was basically just a block of HTML that we bound uh, and provided with two-way binding to the values that it supplies. So the result is basically this page. And just a couple minutes, let's look at charting. So charting basically, I think we have even seen this example on the slides. The other one is basically a radar chart, actually two radar charts combined with two different data sets and rendered using chart.js. And the way we put everything together is in the app.fs file, in the main whole template, the page content is the master placeholder. That is populated by this render inner page function, which looks at the current page value, which is in our state. I don't know. I don't think I've actually explained this. But when we defined our client SPA, we gave an endpoint type to represent the three different pages, and then we created a router based on hashes. So if you look at the URL, we have the URL and then slash hash slash something. So that means I can refresh any one of these pages and it's still serving the index HTML to me. And the form, the logical sub page is then fetched or retrieved from the part of the URL that comes after the hash. So all of that magic is basically routed install hash. And that gives us a current page, which is always a reactive variable of the current endpoint, which is the active one. So I can just look at that. And if it's home, then I render inside the page content placeholder of my SPA, the home page or the charting page or the forms page. And we have seen how these are structured, but let's just look at one of them. The forms page takes yet another bigger template, and just that template has one single placeholder called form container. And then we just use the two functions that we have seen, that the credit request and the validator form, and then we just put those two things into that form container. The charting page similarly constructs a charts whole page, which has a container, and then into that we are plugging in the two charts, which also uses another template with a different title, and then the chart placeholder is the one where we can plug in the actual chart implementation. So everything is template based, everything is weaved together from these lots of nested inner templates. You can sometimes, if you need the server, you can pass the server into these functions, and then those functions are free, like we have seen, to call the server and populate the data that they receive and make something on the UI based on that data. So I think that's pretty much it. The whole application is on the order of about 300 lines. And I think it's a pretty good example to those people who are interested in completely externalizing their presentation artifacts into the template file and have all of their application code just completely free of presentation layer. So this also means that if you take the same application, but if you plug in a different index.html, you can change the entire UI, obviously with the caveat that you need to match the same templates, the same placeholders in them, etc., etc. But if you don't break that contract, you can swap out the entire UI to something drastically different. Of course, this particular template handles the dark and the light themes, so it's quite capable already, and I think it makes a good starter application. So I think what I'm going to do is basically ship this repo as a starter WebSharper template that you can just use easily by either cloning the repo or installing it as a NuGet package. All right, so hopefully you learned something new from this. I hope that you will find that F# is a wonderful language to develop web applications, and WebSharper makes that super simple. Coming from hydration, full stackness, um, forms, abstract forms, reactive programming, all in one package is really fantastic. So I thank you very much for your attention. If you have any questions, I'm going to be here online trying to answer them. And please get in touch using my Twitter or my other social media um, accounts. So thank you very much again, and have a good day.